Gas laws. Boyle's Law.
Boyle's law is a gas law given by the chemist Robert Boyle in 1662. He stated that the pressure exerted by a gas is inversely proportional to the volume occupied at a constant mass and temperature.
Example 1. Let's begin.
Example 2. So I'm going to shake the soda bottle to increase the pressure inside, and then since it's unopened, the pressure will increase, and when I open it, the pressure will decrease, making the soda fizz out, which is Boyle's law. Okay.
Example 3.
Stop laughing! Oh my god! Do it! There's a hole in this, that's why.
Example 4.
With equation.
Hey, I have a question on paper 1.
Okay, what is it?
A gas occupies 12.3 liters at a pressure of 40 mmHg. What is the volume when the pressure is increased to 60 mmHg?
Okay, so for this problem, you're going to want to take the numbers provided to you in the problem and plug it into the equation. P1 times V1 equals P2 times V2. And when you do that, you're going to get 40 mmHg times 12.3 liters equals 60 mmHg times X, where X is going to equal 8.20 liters.
Thank you so much for the help.
Oh, you're welcome.
Alicia, come here.
Yeah, what's up, Grace?
I have another question. So, a gas occupies 11.2 liters at 0.86 atm. What is the pressure if the volume becomes 15 liters?
So basically, all you have to do is use the equation and plug in the missing variables. So in this case, it would be 11.2 liters times 0.86 atm equals X times 15.0 liters. And when you solve that, it is 0.642 atm, which that's X, so yeah.
Okay, thank you.
You're welcome.
To recap what we learned today, Boyle's law was created by a chemist, Robert Boyle, in the year 1662. Boyle's law applies to gas, stating that the pressure and volume of gas are universally proportional to each other when the temperature and the quality of gas are kept constant. First, we learned that placing a marshmallow inside a syringe and using the plunger to increase and decrease the pressure, you can see the marshmallow expand and shrink to get a clear understanding of Boyle's law. When the syringe plunger is pulled out, the volume of the chamber increases, but the amount of gas remains constant because it is in a closed system. When the pressure inside the syringe chamber decreases, the marshmallow's volume increases according to Boyle's law. So it is shown that as the pressure decreases, volume increases, having an inverse relationship. Next, you learn that in accordance with Boyle's law, when you open the soda, you can increase the volume so that the pressure the soda is under decreases. When you take the top off a bottle of soda, the pressure inside the bottle decreases and goes into the same pressure as the atmosphere. Shaking a bottle of soda mixes up the bubbles from the surface and distributes them all throughout the soda, sticking to the sides of the bottle as well. When you open the bottle, all the bubbles float to the surface at once and there's an eruption. There are so many bubbles all going to the surface at the same time that the soda gets trapped between them and carries out the top with the gas. So it is shown that as the pressure decreases, volume increases, having an inverse relationship. Then, we saw how Boyle's law describes the relationship between pressure and volume. When increasing pressure, a gas will decrease its volume. When the side of the diver are pressed, the water is forced into the dropper, decreasing the volume of air in the dropper. This makes it more massive and dense, causing it to sink. When the pressure is released, the opposite effect occurs and the dropper rises. So it is shown that as the pressure decreases, volume increases, having an inverse relationship. Finally, we learned how you can solve a problem about Boyle's law by using the equation P1 V1 equals P2 V2, with P1 being first pressure, V2 being first volume, P2 being second pressure, and V2 being second volume.
Gas laws.